Mr. Richmond, this is your Integrated Math 2, Unit 13.6 and 13.7 lesson summary. We're going to combine these two videos together for these sections because they do relate together. 13.6 is really giving you the skill set that you need to then apply to problems in section 13.7. So what are the skill sets we need to know? Well, it's going to go over square roots and radicals, and this should be reviewed for most, but just in case it's not, I'll go over that briefly. They're going to talk about what the square root of 9 is. Okay, square root is our symbol, kind of looks like a check mark with a line going over a number. We call that number that's under the square root symbol the radicand. And the answer to a square root is basically what number times itself equals the radicand. So what number times itself equals 9? Well, that would be 3. You can also do that with variables. This is where it gets a little trickier. So like the square root of x squared, what is that? Well, that's asking what number or variable or expression times itself equals x squared. Well, x times x equals x squared. So the square root of x squared is x. So that's the idea. Another way to think about it is anytime you have a squared term, something to the second power, if you square root it, it undoes that. It's the inverse of it. You lose the square root, you lose the square, you're left with the radicand. Okay? And that's what we're going to apply here to help us solve some quadratics. Before we do that, let's also make sure we know how to simplify square roots, because we do not want to use decimal answers if we don't have to, because the decimal answers are kind of wrong, they're rounded. So if we can keep them as exact roots, we'll have more accurate answers. And you should have already had to be doing this, honestly, throughout this course in geometry. So hopefully your teachers have been kind of teaching that already, but just to kind of make sure we're still there, it does pop up in this section in the homework, and we'll practice that again. Why are we learning that? Because we want to be able to do completing the square next, which is a process for writing a quadratic equation in vertex form that allows you to then solve for the roots. It's useful when our quadratics are not factorable. So far, everything that we've tried to solve for x in like a quadratic like, say this, has been able to be factored via diamond or GCF, and so you can get the answers. Well, what if you can't factor it? Well, then what do? That's where we're in some trouble. Completing the square will be the solution for that. So let's get started by first finding some roots. What's the square root of 144? It's whatever number times itself twice equals 144. Well, that's just 12. And in all honesty, you should have most of these perfect squares. That's what we call it, perfect square when it works out to a nice number. You should have these memorized, to be honest. Okay, square root of 36 is 6. However, there's a negative in front. That always gets done last. So that answer would be negative 6. Here's where it starts to get trickier. When you don't know the square root of it, there is no number times itself twice that equals 200. That's at least a whole number like this. So what do? I break it down into a multiplication problem that does multiply to 200. I want it to be numbers that I can eventually do the square root of. So you want to try to make that multiplication problem something like 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, etc. So that's what I did here. I broke it down into 2 and 100. And the product rule here with radicals states if you have two numbers being multiplied under a radical, you can write them separate. Root 2 times 100 is the same as root 2 times root 100. And now I just take the square root of them. Square root of 100 is 10. Now, 2 can't break down any further. There's definitely no perfect square that goes into that because it's less than 4. It's just a matter of rewriting it in a more kind of appealing view, which is putting the constant, the regular number in front of the root. So I would simplify it down to 10 root 2. So what happens in a problem like this? I have 5 root 54. Same process. The 54 needs to be simplified. Let's see, what multiplies to 54? 9 and 6, I believe, does. So it's 5 times root 9 times root 6, because 5 times root 9 times root 6 is 5 times root 54. And I just take the square roots for the ones that I can. The square root of 9 is 3. I can't do the square root of 6, so it stays root 6. And notice everything's connected by multiplication in this problem, so everything stays connected by multiplication. I can't extract anything out, really. And now it's just multiplying. 5 times 3 is 15. I still can't times by root 6 really, so it stays root 6. And that's really just a review of how to simplify radicals. Now, in case you're ever stuck without a calculator and you do have an answer that's a radical, you need to use it. Maybe you're in construction, you're working on a building, you're sawing some wood, you're doing anything like that. At this point, you know you want to make it say root 96 is the math you came up with, but now you got to physically chop this thing up. All your rules are going to be in units like 0.1, 0.2 inches, 0.3 inches, or centimeters. So at that point, you're going to have to start approximating. So how do you do that if you're stuck without a calculator? Well, you find the roots that are closest to it. So what's close to root 96? Well, root 100 I can do. And the next lowest one would be root 81 I can do. Root 81 is 9. Root 100 is 10. So root 96 has to be somewhere between 9 and 10. The question is, what decimal is the best choice? I'm going to look at the range here. From 81 to 100, 96 is a lot closer to 100. It's only 4 away from 100. It's 15 away from 81. So this has to be closer to like 9.9, 9.8, something like that. And it's just a matter of now checking. What's 9.8 times 9.8? That's 64. 9 times 8 is 72, and 6 more is 78. Carry a 0. 9 times 8 again is 72. Carry that. 9 times 9 is 81. Is 88. So that would give me 96.06, which is awfully close. So I know it's not quite 9.8, but it's probably something really close to that. So depending on what they want you to round it to, they said the nearest 10, I'd probably say 9.7. But I would say now, I just go 9.79's got to be pretty darn close to what that is, because I was really close to 96 using 98. Okay, and that's kind of the idea there. And it just depends on what your teacher wants you to round to. Some might not even really care about verifying multiplication. As long as you take a good guess between 9 and 10, that makes sense. They're probably going to be happy. Okay, same type of process for root 7. What are the closest roots to root 7 that I can actually do? Well, I can do root 4, or I can do root 9. Root 4 is 3. Or sorry, root 4 is 2. Root 9 is 3. And 7, 5, 6, 7, 8, 9. 7 is literally smack dab in the middle of that. So I want to try something like 2.5 first, because 7 is right in the middle there, range-wise. So what's 2.5 times 2.5? That's 25. 5 times 2 is 10, plus 2 is 12. Carry down a 0. 2 times 5 is 10. Carry up the 1. 2 times 2 is 4, plus 1 more is 5. I add my numbers. I get 625. And 2 decimal places, so this rounds over 2 decimal places. I'm at 6.25, which is not quite enough. It's still not exactly 7. So I can do the same thing again for 2.6. I can go up by 1 and see if that gets me any closer. That's 36. 12 is 15. Carry a 0. That's 12 again. 4 is 5. And now I have 6.76. And I'm getting closer. And I could then try another number, see if it's 2.7. 2.7 here is probably going to put me over though. So I can approximate it and say it's around 2.6. Again, it just depends on how accurate you really want to be. But really it's just getting to the point of how to approximate, get an idea. In our day and age now, this is kind of becoming obsolete because of cell phones and technology like that. You always have some form of calculator there. So if you needed a square root, you probably could just refer to your calculator on your phone, etc. But, hey, here it is just so you know. It's good reasoning practice. All right? Now let's take this and apply this to how to solve equations. So the key here is if you don't have two variables, you only have the variable t or x or something squared, then you don't need to factor. You can't actually factor unless you have an x squared and an x term. So in problems like this, it's just a matter of isolating it, just like you would with regular equations, and then getting rid of the square by square rooting both sides. When you square root the square, it becomes just t, and then you square it 16, and you get 4. Now, here's the tricky part, and this messes a lot of students up. When you're asked to get a square root, you say 3. Square root of 9 is 3. But when you solve an equation, something tricky happens. When you take the square root in an equation, you do it to both sides, you end up having to do the positive and negative root. So let me explain why. T is 4 is correct. Let's plug it back in. 4 squared is 16. But if t was negative 4 squared, change it to a positive is also 16. So we end up missing one of the answers if we don't do a positive and negative when we square root. But it's really only required if you do a square root in equations. When you do it in an equation, it's required. Next one. So here I have x squared and 20. So I would again square root both sides. And I get x equals plus or minus the square root of 20. Don't forget your plus minus. And if the root isn't perfect or a perfect square or anything like that, you can't work it out, then you just simplify the root. So what does 20 break down into? 4 and 5. So I'm going to break it down into root 4 times root 5, which is plus or minus 2 root 5. And now I have it in a nice simplified fashion. Now what's also nice about this is it doesn't just have to be a single variable squared. If you got a set of terms squared, something in parentheses squared, it works exactly the same. So even in something like this, I could just square root both sides of the equation. The square root undoes the square, leaves me with x minus 2, which no longer needs parentheses now because there's nothing being done to it. And on the right side, I have plus or minus the square root of 25, which is 5. And it just means I have an additional step. I have to continue isolating x. This stays plus minus 5 because it was a positive square root. I'm going to add 2 to both sides. And I get plus or minus 5 plus 2. Well, what's that mean? That means my answers for x are a positive 5 plus 2, which results in 7, and a negative 5 plus 2, which results in negative 3. Now let me show you that they're correct. Let's plug 7 in. 7 minus 2 is 5. 5 squared is 25. Negative 3 minus 2 is negative 5. Negative 5 squared is 25. So it still is possible to get the two answers when you take a square root because of that plus minus. And what you've created here is basically the idea and the process for completing the square. It's what we're going to do to solve quadratics that are not normally factorable. So this is now moving you into the realm of 13.7. So first, everything up until now you've probably seen 13.6, and then in 13.7 we're going to apply these skills to solve quadratics. So let me explain how complete the square works first. If I had an expression like this, I could just diamond factor it. However, if it's not diamond factorable, I don't have a way to solve it. So what do? I subtract that c term over, or add it if it was negative, giving me just what's on the left side. And then I'm going to add a particular number in that makes it factorable. Well, what number do I add? I'm going to use a perfect square trinomial, the factor method we learned last lesson, because I know those always factor into a nice, perfect way. And there's actually a special little formula for finding that. It's this. B over 2 squared. All you have to add to any quadratic to make it factorable is the number b over 2 squared. You look at the middle term that's attached to x, you cut it in half, you square it. So let me give you an example. If this is what you ended up with and you want to make this a perfect square factorial, all you have to do is look at the 10, divide it by 2, that's 5, square it, it's now 25. And that becomes factorable. Do a diamond for that. I'll let you do that on your own. I'll show you what that becomes because I can do these in my head at this point. If you factor that, you get 5 and 5. And so that is x plus 5 squared. And so if this is an equation, you've now made it so that you can take the square root of both sides, just like we did here. So let me show you what that would look like in a real problem. Because it wouldn't be like this. You have some homework problems where you're just practicing filling in the blank. But really, this is what we're applying it to. If I gave you the equation, x squared minus 10x minus 3 equals 0, and you tried to solve that, let me show real quick, and do a diamond. That's the only way you're going to factor that trinomial. You have negative 3, negative 10. 1 times 3 is all that multiplies. There's no way that adds or subtracts to 10. I can't factor it. I can't solve it. Not anymore. What do I do now? If that happens, I add the 3 over, or subtract it over. Since it's minus this time, I add it over. And I have x squared minus 10x plus blank, because this minus 3 is gone, so there's something that's now missing from that spot, and it now equals 3 because I've added the 3 over. And now it's a matter of just looking back at this idea, taking half of the b term and squaring it. Half of 10 is 5, squared is 25, and adding it to the left side. What that does, though, is it makes your equation unbalanced. Remember, equations, if I add something to one side, I have to add it to the other to balance it out. Since I've now added a 25 to the left, I add a 25 to the right, and everything is balanced still. I've changed it slightly, but not for reals because it's an equation. I just put more weight on both sides. This is factorable now. It'll factor this, and I can solve it like I did in C. So I know that's kind of tough to follow when you're seeing it in this kind of abstract way, so let me show you some actual samples. Okay, and in our sample problem here we have x squared minus 8x minus 12 equals 0. I'm going to try to solve this by completing the square. The reason I'm going to do completing the square is I can't factor this. Now, on a test, you might not know you need to do complete the square for it. You're probably going to have to try to factor it first. You're going to look at the numbers. You're going to get 6 and 2 is the only thing that can become 8. Something has to be negative to multiply to a negative. If it's 6, it doesn't work because it's negative 4. If it's negative 2, it doesn't work because it's positive 4. I cannot add to this, so I cannot factor. When that happens, I am forced to complete the square. So really, always try to factor the trinomials via GCF or diamond if you can first, and then if that's impossible, you resort to completing the square. First step, isolate the variables by adding 12 to both sides. Okay, that gives me x squared minus 8x, and then I'm going to put something in that spot because I do want to make it a perfect square trinomial. I just don't know what that's going to be yet, and it should now be equal to positive 12 since I've added the 12 over. Now I do that complete the square process, b over 2 squared. b is negative 8. Negative 8 over 2 is 4. 4 squared is 16. I'm going to add 16 to both sides. Got to keep it balanced though. The left side has been changed. You added 16 to the left. You must add 16 to the right to balance it out. Now you can factor. You can diamond factor that. That would be what multiplies the 16 but adds a negative 8. Well, that would be negative 4 and 4. So that factors to x minus 4. Since it's a repeat factor, I can write it as x minus 4 squared. And I just add the right side up. 12 plus 26. Sorry, 12 plus 16 is 28. And now it's just like solving C. So I'm going to do that same process. I'm going to square root both sides of the equation. Remember that when you're square rooting in an equation, you must have a plus minus for any numbers you take the square root of. So I'm doing plus or minus the square root of 28. I'm going to go ahead and change that into a simplified root though. 28 breaks down into 4 times 7, and the square root of 4 is 2. So this would simplify to 2 square root 7. And now it's just a matter of adding that 4 over. Now I'm going to show you that it is a little odd if you just do it the way you're thinking, which is add 4 here. Now that's fine, the way I wrote it. It's nice and spaced out, it's easy to see. A lot of kids don't do that. They add the 4 over, and they add it kind of close. And let's be honest, you guys are kind of sloppy. Come on now. And we can't tell if that root goes past the 7 and over the 4 or vice versa. And heck, half the time you can't either. So you just put 2 root 11. We don't want that to happen, and we don't want to risk that mistake. So don't write the addition or subtraction number behind the root. Always try to write it in front of the root. So I write this instead, x equals 4 plus or minus 2 times the square root of 7. And that is my exact answer. It's those two expressions, 4 plus 2 root 7, 4 minus 2 root 7. So if you want to know what they are as decimals, it's just a matter of working that out now. Literally just do 4 plus 2 times the square root of 7, enter, and see what you get. So if you're not into the whole root thing, you can say x is approximately 9.3. And then I can do 4 minus 2 times the square root of 7. And so negative 1.3. And those are the approximate answers for x. In the real world, if I had to cut something to fit this or spot something like that, these numbers would be fine. In the math realm, we want everything exact. We want to be perfect. We want to have it not have any rounding error, so I'm going to leave that answer like this. So make sure you're able to do it like this. Okay? Let's look at B now. Same type of process. It's going to be a little bit trickier though. Again, I can't factor that. Only thing that multiplies to 1 is 1 and 1, and 1 and 1 won't add to 3 or subtract to 3. So my first step again, add that 1 over to both sides to isolate it. And then I'm going to go ahead and set up my complete the square expression in preparation. What is my complete the square number? Well, 3 over 2 is 1.5, and 1.5 squared is something. So decimals are not your friends here. Fractions are. I know that sounds crazy, but fractions are your friends. Don't ever forget that. They can make, especially when you're working with squares and multiplication, fractions are actually a lot easier than decimals. So let's do it as a fraction instead. 3 over 2. Well, hey, 3 over 2 is a fraction, and he's okay with that. 3 over 2 is 3 over 2, and then I need to square that term. That's actually easier to do. 3 over 2 squared is like 3 over 2 times 3 over 2. 3 over 2 times 3 over 2 is 9 over 4. And so what I'm adding to both sides is just the fraction 9 over 4. So don't be afraid of fractions, they are your friends. But now you got to factor, and factoring fractions isn't very friendly. But I got a way around that. How I'm going to factor this is by using the trend that all perfect square trinomial factors have had. You know that this is a perfect square trinomial because you did the complete the square process on it, just like you did in all these. Okay? So it has to factor in the same way these other ones did. It ends up just factoring to half of b anyways. X plus half of b squared. X minus half of b squared. X plus half of b squared. What's half of b? 3 over 2. So x plus 3 over 2 squared is what that factors to. And now on the right side I have to add fractions. Oh my, oh me. Difficult task. Not really. Just make a common denominator. 1 can become 4 over 4. And you're going to add to that 4 over 4, 9 over 4. 4 plus 9 is 13. So it's 13 over 4. And now I have the exact same process I had in A. Nothing changes. It just has fractions, which makes it scary to some of us. We're not going to get scared. We're just going to put x plus 3 halves equals plus or minus the square root of 13 over 4. Now, here it does get a little tricky. So let me work on the second board here so you can see a little bit more. But my last step is going to be to subtract the 3 halves over and isolate x. But I can do a little bit more of it than just that. So let me rewrite it. It's x plus 3 halves equals plus or minus the square root of 13 fourths. We haven't done the square root of any fractions in this class yet, so let's talk about that. It's really not much different. I can just do the square root of the top and the square root of the bottom separately as long as it's possible. If it's not possible, just leave it as a root. So I cannot do the square root of 13. That's just root 13. Nothing goes into it. I can, however, square root 4. The square root of 4 is 2. So you can actually just simplify that to plus or minus root 13 over 2. And now it's a matter of subtracting x over. Remember what I said here. You want to put it in front because it's just easier to read. It prevents you from making mistakes here later. So I'm going to leave it like that. And I do have my answer now. It's x equals negative 3 halves plus or minus root 13 over 2. And there's nothing wrong with that answer other than that us math teachers are a little bit picky. And those are common denominators. So I want to see that become one fraction. The numerators can add together, although they're not numbers that actually add together. They just come together. And they're shared over the common denominator of 2. And this would be my geeky, mathy, technical answer. Okay? My usable answer in the real world is probably going to actually be what this calculates out to. And notice again, since we have that plus minus, there are 2 potential answers for x. Okay, negative 3 plus the square root of 13, then divided by 2. So I just work out the numerator first, then divide it by 2. That's approximately 0.3. The other answer for x, I just do the minus. So I'm going to do negative 3 minus the square root of 13. Work that out, divide that by 2, and I get approximately negative 3.3. So depending on what your teacher wants, you can give them either answer. Most math teachers are going to prefer this, want to work you toward this. But in Math 2, honestly, it's not all that big of a deal yet, so decimal answers are fine. But do expect when you get to Math 3 for us to really push this being the only correct answer on here. Okay? So hopefully that helps. Complete the square is a little bit difficult, I understand that, so make sure you practice it. The good thing is there are lots of resources for how to solve by completing the square. It's a pretty common topic in all books. So you can use other YouTube videos. My feelings won't be hurt. You can use other resources. Again, my feelings won't be hurt. Get all the help you need, but at least this gets you on the right track. I do understand 2 examples probably isn't enough to get you all the way there, especially if you have trouble typically. So use other resources as you see fit, okay? Good luck. This is it for the chapter. I hope you do well on the test. Thank you.